in the main function, the code first load the value of 0x30 into the register R0, and then copy the value of register R0 into the register R5 by using move instruction. Move instruction is used because the value that wants to load into R0 and R5 is 1/2 word. Okay. Next, load the memory address of 0x40000030 into R1 and load the value of 0x45785612 into the register R2 by using LDR instruction. LDR instruction used because the value that want to store that want to load into R1 and R2 is 1 word. And finally, store the value in R2 at memory location pointed by R1. And then the expected result of execute this program is that the value of 0x45785612 will be stored into memory location of 0x40000030, and the register of R0 and R5 will be same, which is 0x30. Okay, this is the memory location pointed by R1. Okay, that's all for question 1. Question 2. The first function start by load the value of 0x20FE5690 into the register R1 by using LDR instruction. The second step loads the value of 0xFE123089 into the register R2 by using LDR instruction also. And the third step loads the value of 0x34589710 into the register R3 by using LDR instruction. LDR instruction used because the value that want to store into the value that want to load into the R1, R2 and R3 is 1 word. Okay, the next step is add the value of R1 and R2 and set it into the R7. Okay, R7. Add value of R1 to 0 FE5690 plus FE12 FE12 Okay, the first R7 is 1F108719. And the second R7 is by adding the R7 before with the R3, which is the new R7 will get and new R7 will get 53691E29, and this is the final answer that we will get, which is R7. Okay, that's all for question 2. Okay, question 3. Okay, the program start with load the value of 0x2936FEDA into the register R8 by using LDR instruction. This is because LDR instruction is used for one word. Okay, slow. Yeah, and we get the value of R8 same with the when we set it before. Okay, the next. Okay, we perform an arithmetic shift right on the value in R8 with 4 bits, which is and which is okay. The actual value is in bits. The actual value is 2936 FEDA, and we write in bits. So in this case, we perform uh, arithmetic shift right on the value of R8 with 4 bits. So we start the new we start we shift it 4 bits. So the value of 0012, which is 2 will start the next 4 bits here, which is 0012, and so on. And this and the first 4 bits before will be filled up with the most significant bit, which is the first one, which is a 0. So it will fill up with 0. So and we get the answer is 02936 FEDA, which is same with the value of R1. It will perform an ASR instruction. Okay, the next one is perform LSL instruction, which is the value of R8 will be shift to the left 4 bits, and we get or the value of R2 is 0x936FEDA0. Okay, this is how it work. Okay, the first one is the value of R8, and it will shift to the left with 4 bits. So and the first 4 bit will be filled up with 0, and we get the answer is 936F EDA0. Same with the value of R2 when it perform of LSL instruction. Okay, the next one is ROR instruction, which is perform a rotate right on the value of R8 by 4 bits. Okay, and we get the value of R3 is 0x8293 6FED. Okay, this means that the bits are shift to the right. It shift to the right, and the bits that fall off the right, uh, the bit shift to the right, and the last one for actual bits will be rotate to fill up at the first 4 bits here, and we get the answer is A2936FED, which is same with the value of R3 before. That's how ROR instruction perform. Okay, that's all for question 3. Okay, this is question 4. This program start with loads the value of 0x6398 into the register R1 by using MOVW instruction, and then the second line loads the value of 0x1DFE into the register R2 by using the move W also. Move W instruction used because the value that wants to load into the R1 and R2 is the lower half word. This is a value R1 and this is a value R2. And then finally, the operation OR will use to get R3. Operation OR with R1 and R2 used to get the value of R3, which is the value of R3 is 0x00007FFE. R1 and R2, R1 or R2, which is R1 6398 bitwise or with R2 1DFE. So the value is 7FFE, which is this is lower half word. Same with the value of R3. Okay, that's all for question 4. Okay, this is for question 5. The program start with load the value of 0x01 into the register R0 by using move instruction. Move instruction used because the value that want to load into the register R0 is 1 byte. Okay, the second, load the value of 0x40040000 into the register R1 by using LDR instruction. Okay, the next, load the value of 0x40040000 into the register R2 by using LDR instruction. Okay. The next line, load the value of 0x40040020 into the register R3 by using LDR instruction. Also, LDR instruction used because the value that want to store into the register R1, R2 and R3 is one word. Okay, next, load the value of 0x0D into the register R7 by using move instruction. Okay. The next we go in. Okay. First, I want to run the program. Okay. This is R1, R0, R1, R2, R3, and R7. Okay. Next, we jump into the loop ulang. Okay. Within the loop, the value in R0 is stored into the memory at the address in R2. Then the value in R0 is decrement by 1. Is increment by 1, which is will plus 1. R0 will plus 1. So we will get the value of R2 that we increase, that stored in R0. We increase R2 and we get the value of register R2 is 0x40040001. 40040001. Okay. Within the loop, okay, the first memory we get is 01 for the address 0x40040001. Okay, next, the loop will continue until R0 will is same with R7. R0 R0 compared to R7 by using CMP instruction. Okay, and we see it. Okay, R0 first memory address, R2, and we get 4002, and R2 will address memory will get 02, and it will loop until the value of R0 same with the value of register R7, which is 0D, which is 0D in hexa is 13. And we look and we see the memory will increase, and it will stop at 13, which is 10. Yes, at 13, 0C. Okay, next R3. R3, no. Okay, R7. Okay, next, when the value of R0 is equal to R7, it will jump into the another loop, which is ulang 1. Okay. Within this loop, a byte of data in load, a byte of data is load from the memory location in R1 into register R5, and then the byte of data is stored into the memory location in register R3, which is this, by using addition instruction. The memory address in R3 then increment by 1. Wait. For the strb instruction before, the memory address in R3, okay, for the first in loop ulang, I repeat, a byte of data is loaded from the memory location in R1 into the register R5, and then the byte of data is stored into the memory location in R3, this, by using strb instruction. LDRB instruction is used because the value that want to load is 1 byte, and strb instruction is used because the value that want to store is also 1 byte. Okay, the memory address in R3 is increment by 1, and the value in R7 is decrement by 1, which is addition. By using addition, R3 is increment by 1. The value of register R3 is increment by 1. And then the next line, by using sub instruction, the value of R7 is decrement by 1. So the loop continue until R7 is equal to 0. The loop is continue until R7 is equal to 0. Okay, the next checks if the R7 is equal to 0, and if the R7 is equal to 0, so uh, the program will stop. And this is the memory content for memory 1 and memory 2. Okay, that's all for question 5. Question 6. It start with the main function start with load the value of memory address 0x400040020000 into the register R0 by using the LDR instruction because it was one word. Then the second line, load the value of memory address which is 0x40020010 into the register R1 by using LDR instruction. Okay. Next, the program. Wait. Okay, this is the first R0, then R1, load R1. Okay, the next step, the program loads the value of the num constant into the register R2 by using LDR instruction, which is the value of num is has the value of num is 3. Okay, the next one. MP. So, the next step, by using CMP instruction, compare the value of R2 with compare the value of register R2 with 5, which is the value of register R2 is num, which is 3. So when it's compare the value of 3 and 5, it will get the value of R3, R2 is less than 5. So it will what we say, it will skip a BHI step, which is besar, and it will add the value of register R2 with 0x60 to R2 into R2 and store it the result at the memory address pointed to the R1 and jumps to the lompat label. Okay, this is R2. This is R2. When it have add the value of R2 which is 3 with a 0x60 60 with 3, and we get 63, which is the hexa number of R2 is 0x00000063. Okay. The next step, the value of R1, the result at the memory address pointed by R register R1 will save the value of R2, the new R2, which is we add it before with 0x60, and we get the memory mapping which to the 0x400 to 0010 with 63. Okay, and the besar label store the value of R2 at the memory address pointed by R1. In this case, in this program, the value of besar does not exist because when we compare the value of register R2 and 5, we get the value of R2, register R2 is less than 5. So we skip the step besar. Okay, and the last one, the lompat label. The lompat label is no operation instruction, which is it does not effectively nothing. Okay, that's all for question 6.